Computer. Lights.
Good morning, everybody, and happy Thursday. We've got an interesting show for you today while I work on finally getting the stars figured out from my star charts and squared away and everything like that. So, without further ado, let's ado. What does without further ado mean anyway? Does anybody know? I don't think I know. Okay. We are almost ready to do stuff. So here's what's happened. Here's what's happened since the last time you were here. We don't need you anymore. Nope. We don't need you. Nope. We don't need you. No. Nope. Okay. So since the last time we met, I couldn't quite find any way to figure out the math that I needed. So instead, what I've done is I've set up a situation here, or rather a rig, which allows me to place things on here. So this is, if you were to take a Cartesian grid or just a grid system and move from Earth and go out to here, making a mark at every parsec, this is where you'd be for our stars that are in the Bellatrix area. Okay, so what we're doing here is we're just taking the data we already have. We already know what degree around the sun the Bellatrix is at. In this case, Bellatrix is at 196.9 degrees from zero, from the solar, or from the galactic center, which is this way. And it is then 77.3 parsecs out, which puts it right there. The last thing we need to check is that we need to make sure that we have its altitude figured out. Right, 15 degrees. It's 15 degrees down angle, which isn't really a whole lot, right? So that's about right here, which pulls it back from, I want to just make sure I double check this, that pulls it back from 0. So this thing tells me how far back does it go, right? So here's 10, here's 15, and it goes back exactly 1/10 of a parsec. So it's going to pull back across the map 1/10 of a parsec. But it's also going to go down minus, so about that far down. But out here, that's a long ways. So we'll have to figure that one out a little bit later. We can, using this larger grid, like how far down does that go at 15 degrees? Because 15 degrees is actually pretty significant at 70 something, but that's not what we're worrying about right now. So 15 degrees is back 1/10. So it's 77.3. And we're going to go up here to the markers. All we're doing here is trying to check it, though. Okay, so we're trying to check it. 77.3 minus 1/10 is going to be 77.2. So here's 77 and here's 2, right? And that's right, we're not in the right one. So 77.212 puts Bellatrix right there. Which is interesting because on my large map, that's the dot where Bellatrix lives. So at least we know that the L and the B on our spreadsheets match. Good morning, Ghost Hand. I promise I'm not staying on stars this entire time. So, because I have now proven that Bellatrix is at the correct spot. Oh, that was good. Good job. Good job, guy. Bellatrix is at the correct spot on the map right here. So when we turn off all the grids, we get Bellatrix right there. And if we turn on a galactic Cartesian grid, which is this one, and that's the one that matches the maps, we're at 100, 110, 90, 100, 101, 102. So, and now we get to check the numbers against my list. So we're at 102. This is X plus 102. Yes, it could be minus. I'm only presuming that this bottom part is the bottom of the Cartesian grid. 0.1 and y plus 149.9. And if we look over here, the math, that is not the numbers I've got. Oh, that's galactic. Yeah, it's not the numbers I'm getting. Which is part of the problem. It's because these are offset. Right? It's such a good movie. But when you're 16, it's not a good movie. So, one of my favorite movies of all time, is 2010, which is the sequel to that movie. And I love that movie so much. And I showed it to my kid who's 11, and he was like, it was like, honest kid, you like this better when you grow up. It just felt so like, I felt so old. I did. I just felt so very, very old. It was very funny. Okay, we need to change the galactic Cartesian because there's one level of translation here that we're missing. And that one's the one right there we've forgotten. Okay, that means we got to bring up the master plan again. And And we need the local map. Not that one. Master neighborhood map. It's always interesting because I absolutely agree it's a relic of a more hopeful time. But I also find it very interesting in that that movie itself is so intriguing to me. I mean, like the book and everything like that were loaded with politics, which I find interesting as well. Okay. But I always find politics interesting. That may not have been what I wanted to do. That was not what I wanted to do. There we go. Let's make this match a little bit better to the core piece here. There we go. And the reason I'm doing this is because we don't have a good idea of where this grid goes based off of Earth. Right? So this needs to be based off of Earth. The problem is we have a number of different grids. Right? There's an in joke in there. I don't know if you know the in joke that's going on. But the very first computer that was UNIVAC that was set up in, not you, in 19, I want to say 48, maybe 49. They taught it to sing, but it couldn't make any kind. I mean, it just made synthesizer noises. But the song that it sang was Daisy. So Hal singing that song was sort of an inside joke because the first song that a computer ever sang was that song. So when Hal starts going, Daisy, Daisy, give me your answer due, that's totally a callback to the whole concept of that computer singing. So that's what that's a reference to, if you're wondering. Try and place this. 61. In my brain, computers evolved much faster than they really did. It's like in my head, I feel like they did a better job. Okay. just aligning this with the rig here so that we can get this correctly lined up. Looks like it's just down and over one. But that puts these guys at plus 10. This is to the galactic east. So that's galactic forward. This is galactic east. That's galactic west. If we're doing a right hand, but it may not be. It could be a left hand, because that's the way this works. Because nobody, yeah, well, that's true. Well, I mean, we keep talking about these things, but these things are amazing to me, right? I mean, the amount of data and information that's on one of these. Have you ever noticed how much this looks like a monolith? You ever thought that maybe Arthur C. Clarke was talking about something? There is absolutely no way that Arthur C. Clarke could have predicted that. Now, Arthur C. Clarke was an amazing guy. And he kept coming up with, like, we keep talking about the creepy things that Arthur C. Clarke came up with. But there's no way he could have known that. But it does. Doesn't it just look like it could just be sitting there? And it is kind of 1x4x9, right? I mean, you think about it. Space is full of math. So we're going to go back here. We're going to take this guy. We're going to move him over one. And down one. There. And that puts that there. Right? So let's look at this. This is minus 10, minus 20, minus 30, and this is minus 40. So this is going to be minus 40. So we'll write that in. This makes this minus 30. And this is either plus or minus, we don't know, 10 and 20. So this is 10, and this is 0. So this is 10, and this is 0. Bellatrix is almost 180 degrees behind us. And so all I'm doing here is trying to check these numbers. So this is 0, this is plus or minus. We don't know. So one of the problems that we have with the Cartesian system is you can't tell who's on what Cartesian system. One Cartesian system says that positive x is towards the galactic center, and positive y is towards the galactic east, and it means that, and then everything rotates to the left on the circle. It rotates to the left. The other one says that positive x is towards the galactic anticenter, which is the back, and then positive y is still towards the galactic east. So actually, we do know that this is positive. And galactic y says that it's about 15. Right? No, it doesn't. It says it's at 21. negative 21 no less. That puts it here. So now what I'm trying to figure out is, once we've located Bellatrix, and we have, in the literal sense, we located Bellatrix to be right here on the markers side. So this is where Bellatrix sits. If you put it down on a normal Cartesian grid, this puts it at plus minus. (31, 32, 33, 34). So x plus 34 y plus like 11, right? The problem we've got is that my number here, using the same L and B, says minus 71. Puts it a long ways that way. Way off the board. Minus 71, and the galactic y is minus 21, which, if we assume this is a plus or minus, that still puts it right here, somewhere down that way. Which means that the math is wrong, which is what I was trying to figure out this entire time. What's wrong with my math? Right? Well, I can keep manually putting in stars, and that's probably okay. Yeah, let's just keep manually putting in stars. What's the worst that can happen? Okay. Let's start doing art and stop doing math, because the math is just maddening. Okay, so let's do this. We'll turn on the map here. And what we'll notice immediately is that we have what we call the wall. And this is a wall of dust particles and things like that, which rise up right behind Bellatrix. Since this is going to be the map and the grid of everything, what we're going to do is this. I'm going to put the grid with all the stars on the bottom rung of this. And then we're going to put posts that come up in a 3D environment, which have the star on top of it. And each star will be represented. There are about 20 stars or so that are in the Unity at this point in time. And some of them, actually, there are a couple of stars that I'm just not going to mess with, because they originally were part of the star cluster that's around Bellatrix. But once the Gaia probe got in there and I could redo their numbers, it turns out that they were much further behind the star cluster around Bellatrix. So we're only going to keep it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There's 21 stars. 21 stars in the Unity, in the core part of the Unity. So we are going to talk then about the wall. So let's talk about the wall. Way down here on level 1 of the wall is this very bottom. The wall has an opening in the bottom, which is open for reasons. I mean, it's just a bubble. And they call it the local bubble because What probably happened was there was a star here a long time ago, and it blew up. And when it did, it made a hole in the dust because all of that then formed a nebula. The nebula then formed stars. This local group now exists out of that. Bellatrix is actually a very young star. It's not old enough to be completely done with everything. So in our story, the two innermost planets actually are still protoplanets. They're still forming in an accretion disk. So the accretion disk has collapsed into the inner circle, but the Bellatrix star itself has an accretion disk with two planets that are still forming inside it. So because of that, it's still relatively new at the edge of this sort of rig, this setup. So we're going to put in the wall. Let's put in the wall. There we go. I'm going to come up here. Let's see how big that is. That's good. Perfect. And I figured the best way to do this is to do it in sort of how would I put it? Similar to terrain markers. So if we were to come in here and just do, and it's a cloud, so I'm going to form eddies and currents in it and make that kind of look like that in a way. So what we're doing here is just defining sort of the bottom of this wall. Like so. And then I'll actually put like a couple of little extra little islands because there's always little islands that kind of pop out like this. And this is hazardous to space travel in our story. Right, so I have to be kind of careful here, and I can't see very well through my own handwriting. Thanks, me. Right? We'll put a couple of little outboard islands like so. We have to remember that the direction of travel for the galaxy is this way, because the arms move towards the center and they're moving sort of like this. So we want to make sure that I show the direction of travel for the arms so that they're going the right direction. This is level 1. Okay. We'll do the same thing here. We'll call this level 2. We're coming up on the under curve of this. So this is another 2 or 3 parsecs up. The wall is slanted like this, and Bellatrix sits right like this. So it's outside of the wall, but there's an overhang at the top. I actually captured a picture, or I didn't capture. The guy who talks about this stuff captured the picture of this. So let me show you what he snagged, because he's got a 3D model he's been operating on for a while. Here we go. And I'll show you when it's done doing this. Here we go. So this shows right here, here's the sun right here. Here's the sun. Okay, fine. As soon as the pen comes out, it's like it'll let me draw on it. That's nice. Um, there you go. Anyway, here's the sun. This is the wall right here. This is where that wall is. And you can see it's slanted upward at an angle. No, you can't actually see. It's slanted upward at an angle, like so. Here's Earth. And Bellatrix sits right like that. So that's where we're kind of dealing with, is this zone right through here. This is a dust cloud. This yellow back here is a high level dust cloud. Inside here are these H2 high density star groups. These two large spheres, this is the Orion cluster. So all of the Orion Nebula and stuff like that lives right in here. Kind of goes like that. And over here, this is the SCO-OB2 is what this is. So this is all part of the scutum sort of cloud set. So we're dealing only in this area right here for this map. You can see how the wall kind of climbs up and then goes up and over a little out here, but it's not going to on our map. It's just going to climb up. So the next level up here on wall 2 is going to be right back here. We're just going to keep doing the same thing. I'm going to make it interesting. I'm going to give it some change a little bit to it here so that it's not quite as set up straight. Give it some just design differences. This is still underneath Bellatrix at this level, so it's not quite as high up. Like so. And there won't be any islands on this one because if you get stragglers out from the cloud, it's going to be, well, I guess there could be islands out here, couldn't there? Little islands like this. Let's do that. Give it some look. And we'll go up on the third level. On wall 3, we'll just keep moving up. This time we're now past or at level with Bellatrix. So we're going to come along here and just kind of do this number. If this looks kind of like terrain, it's exactly what it's supposed to look like a Cartesian map. Not a Cartesian, like surveyor's map. It's supposed to look a little like a surveyor's map. Because when we are done with this, we're going to do a trick to make this work. we're going to put these all into a 3D program, and we're going to raise each one of these so that when you look at the map, these lines will be in there, and you'll be able to see the actual arc of this. Because this is the wall. Okay. Kind of want to move that out a little bit. Okay. So now when we look at this, we've got a number of levels that show sort of a gradient moving upward. The thing about this is that we want to show that there's a small amount of, particle in there or something to illustrate sort of what's going on in there. And I don't want to necessarily make it hard to see because there will be stars inside the wall. That's actually part of the plot of a little bit of this story, is that she's our intrepid captain is sent back into the wall on the other side. Communications gets a little rough, ship travel is difficult, that kind of stuff. So things get slowed down when you're on the other side of the wall. And Hades cluster is this way over here, going out this way. So the war front is right through here. And so anybody who's sent this way is being sent away from the front. For soldiers, that sucks. They're like, what did I do wrong? So, she's kind of ticked about that, and understandably so. She's going to be sent through the wall to the other side. So we're going to make the map and show the wall as where it is, because that's important. But the other critical thing here is that the wall is, we've got to figure out what to do with the wall here. Whether I want to fill it in with something, I don't know. When we do this, anything white on a black background, the black becomes transparent and the white does not. Anything gray is semi-transparent in 3D. So my thought process here is, maybe what I'll do is I'll just take these levels of wall and make them medium gray. Maybe even a little less than a medium gray, like 75% gray. If I do that, then each one of these levels of wall will be 75% transparent. You'll be able to see through them. We'll be able to make our map, and you'll be able to see the wall behind Bellatrix. Nothing in our star charts are above Galactic Z. No, they're all above Galactic Z. On here, it's what it's saying. So one of the problems is we are not in the center of the galaxy, obviously. The Earth sits about, or the solar system sits about, I want to say, 10, 15 parsecs above the middle of the galaxy. So if you think of our arm as like a pizza, or if you think of the galaxy like a big pizza, then we're not at the center of the pizza, we're slightly above the center of the pizza. So it's kind of one of those things where it's like, where are we on this thing? So this wall, though, goes through all of the pizza slice. So we're going to make a map that illustrates that. But in order to do that, we're going to need to find out how high above center does Bellatrix live. So the truth is, when we look at this is below by quite a bit. This is below by some. And this is the middle, maybe, or maybe right between these two. So 1, 2, 3, 4, 5, 6. See, I didn't make this easy for myself. Because there's not an uneven number here. We need to add another level in here. I feel like that's going to be right here. So let's talk about this. Is that this guy? Yeah. This guy, I feel like, is middle right here, kind of heading out. So we'll do this. Crunch him in a little bit more on this so that he's a little bit more there. And then I'll add one here. All right. So we'll start there. And this guy isn't at the midline. It actually goes underneath that little ledge out there, which is reaching towards Bellatrix. Okay. This midline, well, Bellatrix is above the midline, so we're not going to put the midline there, but yep. Okay, so here's how we're going to do this. The wall 3, this guy here is actually on the grid. So I'm going to take the galactic Cartesian grid, this guy here, I'm going to duplicate him, and we're going to call wall 3 and merge that with the galactic Cartesian grid. We're not going to do it yet, but that's the battle plan. Okay, and the reason that we're going to do that is because this level, and this level are below center line of the galaxy. This level is on the center line of the galaxy. And this level, and this level are above the center line of the galaxy. And that way we can define our little pizza box of things. So let's imagine the galaxy is a pizza box. I really want pizza. I'm just saying. We imagine our galaxy is a pizza box, and we've got that Cartesian grid going through the middle of the pizza box. Stars that are above that pizza box will be lines that go upward. Stars that are below that pizza box will be lines that go down. So that's how we're going to do this. But first, I have to decide how I'm going to deal with these wall lines. I think what I'm going to do is do a 50% on it with a 50% opacity so that we can see it here and there. So that's what we're going to do. We're going to duplicate these things. Take this, we're going to go to a 50%, and then all you do here is just do this. And go 5, 0, enter. That's 50%. We're at wall 1. Wall 1's here. And we fill in that section, right? Then, since we have wall 1 copy, we take this and drop it to 50%. Now you can see through it, right? I actually kind of want it to be darker, so let's go 25%, like that. Right? This way we can see through it still, and we can kind of still see the things underneath it. We actually might even go lower than that. Let's try 10%? Nah. 20%. Oh, come on, work with me here. There we go. Now we take everything else off. Work. And we merge visible. Okay. Now when we look at this, we've got slightly transparent. It's going to be just barely above. And maybe we want a little bit more than that now that I've looked at that. Let's do all this operation differently. Actually, we'll go here. Let's turn on these and then take this and then we'll raise it maybe to 33. So that's a 30 or 1/3. That looks a little bit better. Now we'll merge those two. Yeah, 1/3's better. We'll do the next level and do the same thing. All right. So having done that, we'll bring this down to 1/3, like so. And you can already see it's getting slightly darker, right? Oh, we need to make sure we add the little island. Ooh, did I not add the islands in the first one? I didn't. Oh, man. Sometimes I worry about myself because I'm not thinking. Hit that, and that, and that, because those little islands need to be transparent too. Right. Control Shift E. Go up the wall too. And we'll do the same thing. We'll duplicate it. Hit that. And that. And turn it to 33. Turn that off. And we'll work this. Okay. Now we've got two layers that look like that. You can see that they're slightly darker for each one. It'll look great here. It'll look great when we're done. The wall 2.5. This is the middle line, or just below the midline. So we'll duplicate it, fill it, make sure that there's no pieces we're missing. missing. Okay. We'll take you. And we'll go 33. Same thing. Right. Now we have 3 layers. And with wall 3, we're going to end up actually on the line of the galactic Cartesian line. So once this one's done, once we've finished this job, we're going to go like this. We're going to have a problem. Fill that. Okay. Again, we check to make sure there's no islands. Since I've gotten into this idea of doing islands. 3, like this. This is the one where we can turn on the galactic Cartesian lines as well on the grid. But we should probably turn that all the way up. That way you can see it. There we go. I'm stopping here to think it through just to make sure I'm not making some stupid mistake. Because this would be the time for me to make a stupid mistake. I think we're okay. You know what? I'm not going to do that because it's too risky. We'll turn the galactic Cartesian lines on and work that situation when we get there. Wall 4. We'll do that. And then again, we'll turn on the black background so we can see if there's there's an island. No man's an island. All right. And now we're getting up on the actual where it's curving to the top of the wall and coming back around. Now that I'm thinking about it, I'm glad I didn't put the Cartesian grid in, because one of the things I actually kind of want to do is put in line or numbers to indicate the altitude of each one of these wall pieces, because it is very much like the, what am I thinking here? The maps that show the elevation maps. It's very much like an elevation map. So, all right. The wall. Look at that. Look at that. Look at that. Right. So there we go. This is actually what space looks like in a sort of interesting sort of way, right? So there's that wall. Now the wall is clear. Kind of like it. Looks neat. It's also going to look much cooler when we get to the point where we're ready to put this into a 3D space. Because we're going to have sort of this grid setup, but these things are going to stack up on the side. One thing we need to figure out, though, is how big is our pizza box? Okay, so 1,000 light years, give or take. Is 300 parsecs. So it's 150 down and 150 up. It's not bad. Which means this isn't the entirety of the this isn't the entirety of our setup. We are, however, below. We shouldn't be below Earth, should we? We shouldn't. We should be. It's hard to tell, right? Because part of the problem is that when we think of coordinates on how Earth works, all of our stars are based on viewing the Earth or viewing the stars from standing on Earth, where obviously I see things here in Colorado differently than, say, you would go stand down in Brazil because you're in a different location on the planet. So the stars that you see in the sky are going to be different than the stars that I see in the night sky as well. But since you're almost on the equator, you are at the celestial center when we talk about like the way that we see stars. So the reality, though, is that Earth and the solar system are tilted off the galactic plane. So the galaxy goes this way, and our solar system goes like this. So it's turning like this. You know, the planets go this way across the solar system, while it's moving this way in the galaxy. So when we look up at the night sky and we say, you know, oh, that star is right at the equator, it's really not. It's 30 degrees up from the equator. Or as the planet turns to the other side, it becomes 30 degrees below the equator of the galaxy. And this map is based on galactic flat. It's galactically flat. It's the pizza box of the galaxy. So I've got to think through, where is Bellatrix relative to all the other stars? Is it up? Is it down? Is it below the galactic plane? Is it above the galactic plane? I'm glad I didn't set the galactic plane for this, because really, I feel like, well, I mean, can we get, I wonder if there's a way to do, well, guys, let's stand up and take a break. Oh my goodness. Goodness. So let's stand up and stretch. I know I needed to do that because my elbow popped just standing up. I know that, you know, we think that maybe I'm being a little obsessive about this, and I might be, but I'm enjoying it, so there's that. Okay. All right. We won't be able to do more than, we won't be able to settle this grid down until I can ascertain how far up Bellatrix is. We're kind of back to the same problem we had before with the problem with Bellatrix, or the problem with all of this, is that my math isn't right. Right? I mean, it's back to me fussing with the math to figure out what's wrong. I see parts of the formula that makes me wonder whether, like, this formula has it flipping. It's flipping my numbers over. So, yeah. It's like this number's changed. You changed the numbers. Oh God! But I see these. I'm noticing that in here it's doing pi by 180, and I wonder if that's part of our problem. Right? Because remember how I said one version of how we do Cartesian coordinates has x pointed towards the galactic center, or Sagittarius A star, and the other one has it pointed 180 degrees back towards Elnath. I'm wondering now, because now my numbers read, if you look here with this change, my numbers read 41, 18, 62. 41, 18, 62 might be closer, right? Let's turn off the wall, because that's just going to confuse us. Turn off the galactic Cartesian and turn on the Earth Cartesian. And then turn on my markers. And let's take a look at this with the corrected math. Let's erase things very slowly so that we can all watch me erase for 2 hours. That seems like a fun thing. This one says x41. That's a different number. x41, if we assume that x is going the other direction, x41 is right here, and y is 18, right? So that's 11, 12, 13, 14, 15, 16, 17, 18. That's putting it here. Hey guys, we may be onto something. Let's turn on the coordinates. I mean, that's still off from the 196. It puts it towards 199 as degrees from Earth, but well within error range. and 60 up. It puts it 62 up above galactic center. And what I don't get, and this is something I still don't understand, and this is why I'm pondering and thinking here. Knowing that Earth is right here, by the way, this is much more reasonable. I mean, I would be much happier if it ended up being here rather than there, because at least that would then say that it was just further away, and the numbers for its parallax might be in question, which there are times where I kind of wonder if my numbers to the parallax are in question. Because, and let me give you an important thing to note here, my numbers for all of the other stars are from the Gaia mission. But for some reason, and I don't know why, the Gaia numbers, the Gaia website won't give me numbers on named objects like Bellatrix, which has a named object to it. It doesn't seem to have it in their database, and I think that they do have it in their database because it's consistent. All stars that have a name cannot be found in the Gaia database, which is conspicuous. You can find HD 26126 in the database, but you can't find Bellatrix. You can find HD 24124, but you can't find Betelgeuse. And it's like, that's conspicuous. There's something. So my thought is they have them in the database under some name that we can't find, right? So, I mean, like they have it under some obscure catalog or something. Right? So I'm kind of wondering if there's a trick to it. Because if we go to the search, I wonder what would happen if we hit an equatorial coordinate near, because it says target in a circle or a box, radius 5 arc seconds. Wonder what kind of damage we can get if we hit. This could be cool. So let's try something here. Let's try an experiment. And I know you guys are all like, why are you so fascinated? It does, it's all right. Just go with me here. Work with me on this one. Okay, we're going to open up this so that we can get all of my information. We're going to get its right ascension and declination. Right ascension, declination. There we go. That's what we're looking for. For good old battle Bellatrix. Row 48. So we're looking at, let's write this down, otherwise I won't get it. Right ascension. Row 48. 1.418. Declination. Those are in radians. So I want to give me the actual numbers for this, please. Says guy wondering why I'm doing this. Why, people? Okay, that was weird. Bellatrix. Okay. Right ascension. 5 hours, 25 minutes. And declination is 6 degrees, 20 minutes. That's good enough. So we'll do 5 hours, 25 minutes. And declination, 6 degrees, 20 minutes. Okay, doesn't like it. 20. Okay, this could be the biggest disaster ever. It'll be fun. No results found. There are no stars there. None. No. Gaia data. Where were we? Go this way. Search. Equatorial. Images 6. Okay. So part of this is that I'm having a hard time with what it's looking for. Right? So what is... Nope. This is what we're looking for. All of this actually makes sense to me. I know it doesn't make sense to anybody else, but it makes sense to me. I'm just trying to figure out because it wants me to give it information in ICRS, which is fine, but it's a computer, so it has to be exact. Now here's all the math. Wow. Equatorial to galactic. Well, there's that. Still didn't tell me anything about how I'm supposed to format this. And now I'm just making up stuff. Okay. One of the more frustrating things about this is there's literally like 30 different standards on how we find stars in the night sky. It makes some sense. There has been a great deal of there's been a great deal of Or maybe Sinbad. Yeah, see, it never comes up with a result. I type in Bellatrix and there's no result. Like, there is no Bellatrix, only Zool. I mean, and it's conspicuously weird because, like, even when I look at, say, for example, Bellatrix is HIP 25336, right? It still says there's nothing there. And it's fascinating to me because if I go back here and, okay, maybe you said that wrong, we'll go to the next star down, 25814, right? 14, right? It gets that star. So as long as it doesn't have an actual name, but rather just has a number, it's in the database. If it has a name, like we've named it something, Beetlejuice or Bellatrix or Canopus or any of those names, if it has a name, we can't find it. That's conspicuous to me. Something about the way that it's looking for things. Because, I mean, I can type in anything, right? Antares. There's nothing there. No Vega either. Um, right? Sirius. No. Sirius isn't in the database either. Well, that's interesting. Did not expect to see Alpha Centauri. So, Alpha Centauri gave me a call. Did not expect that. Okay, well, there's that. If we look, though, at Bellatrix's go ahead and Bellatrix Lestrange. We can go ahead and get its galactic coordinates from here. Yeah, I guess I can get its parallax. Let's go to Sinbad. Okay, Bellatrix. Let's see if it'll give me its information coordinate. Nope, that's not what I want. You, where are you? This is optical. Galactic coordinates 196. Let's check our coordinates. 196.92. Yep, that's correct. Minus 15.95. Minus 15.95. Okay. So we also need to find its. Ooh, hey, you know what's here? Look at all these different references. Like, do we have its number? Huh. What I'm not seeing down here is Gaia information. So the problem that I've got is that the Gaia information tightened up where stars were, so the stars have gotten closer to Earth. If they decided with Gaia to not actually hit named stars, you're going to end up with a cluster of stars, like let's say the Hyades cluster, and then Hyades will still be way back here, when in real life, Hyades might be right here. But because this is the older Hipparcos data and this is the Gaia data, the Gaia stars are going to have moved closer to Earth because they're more accurate. And the Hipparcos data on Hyades is going to be way back here, which makes me feel like I need to adjust Bellatrix artificially to make it sit in its spot correctly. AG50, where the heck is AG50? Wow, there's a lot of math going on over here. Celestial X is in the direction of vernal equinox, so true Y is in the direction of right hour, 60, whatever. Proper motion. Ooh. I have a lot of data in my spreadsheet because I'm loath to delete things and then find out that it's wrong. So I'm just closing fields here. Wow. It's not going to be any fun. So one of the things that we've set up is that the Schwarzschild radius of a star increases in hyperspace to the square of the distance to the star. So just realizing that Bellatrix is a big star. So if you do that, its Schwarzschild radius ends up being 415 parsecs at 0.5. So that's not good. I'm going to have to adjust it back. I want them to be hazardous. I don't want them to be that hazardous. The bigger the star, the more its radius around it that's dangerous when you're in hyperspace. But at this point in time, Bellatrix becomes this behemoth that chews up. I mean, like at 415 parsecs, Bellatrix's Schwarzschild radius extends past Earth. So that makes it even funnier because, of course, that's way past what we need to do here. So you wouldn't be able to fly between Bellatrix and Earth because the Schwarzschild radius would. So yeah, that's probably damaged and borked my own. I've been foisted on my own petard. Apparent magnitude, absolute magnitude, color and its luminosity. Okay, so we're not going to get any more information out of this part of it. Celestial X, Y, and Z might be correct, and I'm not sure. But the math in here was absolute. So I'm worried. So my primary concern here is that the math was right if you presume we were working from celestial north poles. So but we already have degrees this way and degrees up and down. I wonder if there's a way. I'm thinking here and kind of trying to crunch the numbers. I wonder if there's a way to get the data that we want. The truth is, so we are pretty sure that the distance of you is about 100 and what are the other identifiers over here? Gliese. I can't imagine you do not have a Gliese one, but yeah. Like there's, maybe it's a Tycho number? I could try. Always try, right? So I can't get, I don't even know how to make this work. Because this would be good too if I could just hit a spot. We could pull up all the data of all the stars in that area and then pull down stars that don't need to be in there. I wonder if maybe if we took name and we say, I don't know. Oh, you know what we could do? If we do right ascension and declination here, you can just take any one of these. Let's say 25814. Right? We submit it. Ah, that's why. Because they're in degrees. So that's fine. There. Now, make this hard. Right ascension 82.69. Declination 8.3. See what happens. No results found. It's a good thing I'm working hard here. Let's do a radius of 10 arc seconds. No results found. That means that it doesn't like whatever it is I'm doing. Okay. So let's do 5 I'll do 6. The hard part about this is always so complicated. I don't know. It shouldn't be this hard. Should be able to find it on the. Yep. Okay, so we found it in Papakros. .34, but essentially it's 81 point. Yeah, okay, see, that wasn't so hard now, was it? PMDE, PMDE, DE, PMDE, PLX, PMDE, PMRA, PMDE, RA, PMRA, PMRA, DE, PMRA, PLX, PMRA, RA. PMDERA, PMRA, PMRA, DE. Okay, I'm having way too much fun with PMRADE stuff. Okay, Bellatrix. All right. It says that it's 77 parsecs out. So no matter what, this 77 parsecs is where it says that it's supposed to be. I think I'm just going to manually put in all of my other stars using this same method, and it'll be fine. And then we'll just find out how far above or below the galactic center we are. And then we'll just leave it that way. And then it'll be fine. It'll be okay. It won't be a problem. And then we can put... So actually, you know what our local resident dude has said already, and he's done this for me? He's done all the thinking for me. Because, whoa, don't write on there. Zoom. Bellatrix. And here's the wall. You can see the wall kind of does this number right here as it heads out into the Mirzum tunnel. The wall flattens out here and then leans back for Bellatrix and then comes back up to here. But he didn't actually, that's not the map I was looking for. He did another one. And I can just make everything the same based off of his existing map. That's the PDF of that local 500, and we don't want to do that because that one's a big, big monster. Like crash my computer big. Local 500. You. Okay, so he's saying the Bellatrix is minus 21. Okay, and I'm not sure whether that's minus 21 on the global or so I'm believing that this is minus 21 below the sun because he's solar based on this. The sun is actually above the galactic plane by 20 or 30. So if we take his numbers, he says minus 21 parsecs below Earth on this level, then that would put Bellatrix just above the galactic plane. Okay, that's cool. So we've got a little bit going on here. Bellatrix starts at minus 21. So he's giving here just a little bit of information that actually works really well. We can use all of this stuff to just give us a basis to start off of. Because I don't need it to be perfect. It just needs to be close, right? If we know that minus 21 equals whatever is on my spreadsheet here at x, says here x10, and x10 equals minus 21. Whoa. Guess what my spreadsheet says? Oh, it doesn't. It says the next one down is at minus 21, or is it positive 21? It's the first thing that my spreadsheet's agreed on from him. Because it says it's reversed. It says it's positive 21, but it agrees 21. The z coordinate agrees 21. Well, if we look here then, and if this is x plus, or maybe this is x plus, right? What did we say the x was on this? Maybe it does agree. Back 20, down 70. Down 70 doesn't match. Right, because this ring represents this is me taking a picture, a snapshot of what he had. But something might be translatable here. What other pictures do I have? What other things do I have from this guy? I'm kind of asking for this in hopes that this works and doesn't actually like make my computer explode. It didn't. Okay, so he's at minus 21. So this is 500. So each one of these is 100 parsecs. This could be 70. Guys, this could be 70. If so, his maps and my maps are somewhat agreeing, right? Maybe part of this is just that I have been presuming a lot. So 1952 equals 100 parsecs. Okay, you need to stop. Just stop. You're not helping me. Folks, this may be right. Hudson may be right. And we may have figured out our problem. So if we say we look at our numbers here, and we say 19, I don't know why I'm doing this. The scale of this is 19, so 20 pixels, 20 pixels to 19 and a half pixels to a parsec. Okay, guys, 71.19, 71.19. Look at that. So what we have on his map and what we have up here agree. We have, for the benefit of argument here, this is the x coordinate right here, and this is negative, and this is x positive. It agrees. This right here is 71.09 by just measuring pixels on here. And what my math says is 71.19. That is well within agreement. So now we know that x plus is towards the center of the galaxy and x minus is away. Now let's double check the second number. So 425.52 divided by 19.5 is 21.8. 21.2. That's far close enough to agree. Negative. So this is y minus, and this is y plus. And that's where we're having a problem with this map, because what this is, if you're looking at it here, is this is y negative y, and this is positive y, and that's why all of my numbers have been screwed up. This is correct in being positive x, and this is negative x. But our biggest problem that we've had is that this is positive y and that's negative. Our negative y goes the wrong direction. And that's why my numbers don't jive. But guys, like, all of my numbers are right. All of these numbers are right. That's exciting. I mean, yes, we've gone through like a ridiculous amount of work to verify that my numbers are correct, but my numbers are correct. They jive. When we look here, we get 71.09. Double check that. 425.52 divided by 5. So this becomes, Bellatrix is x minus 71.09 y minus 2.82 z minus 2, 1. .38. Like 3 days worth of math to find out that my math was right. I just didn't want to believe that Bellatrix was actually 71 parsecs away from Earth. That's the problem. I also think my grid might be wrong. That's all right. We have it. It took us 2 weeks. But better to have double checked than to leave it as it is. As a side note, today is Will Wheaton's birthday. He turns 49. 2 days from now, I too shall turn 49. I say that because I constantly talk about how every time when I was watching the next generation of Star Trek back in the 80s, I was literally the same age as Wesley Crusher. Like 2 days distant, 2 days apart. So Will Wheaton has his birthday on the 29th. He was born on July 29th, 1972. And I was born on July 31st, 1972. So we are 2 days apart in age. So when you watch Star Trek The Next Generation, know that I was sitting there eating my Cheerios going, I could have been Wesley Crusher. I'm just saying. So there's that. That's the thing. We have solved the mystery of this problem. The math is solid. I have now verified my math. I'm happy. The only thing that I am wondering about is he did not put the sun's position. So I'm going to tweet to him and ask him if the sun is his Z0, or if the sun is plus 33. Because if it's plus 33, then everything is correct and Bellatrix is below the center grid of the galaxy. If, however, he placed the sun at 0, then Bellatrix is actually going to be like plus 10 on the Z. And so we'll have to adjust our Z to make everything sit on the galactic center correctly, because the sun is off by a little bit there. Because I'm noticing that his X and Y here is galactically centered. But that's okay. So, I mean, I'm assuming, since that's 71 parsecs negative, that the sun is also, because the sun is at 0x and 0y, I'm assuming it's also 0z, which is fine. Everything gets adjusted to galactic standards using my maps that are galactic, and that would be okay as well. And all that is you take whatever is the x, the y, and the z, and you subtract the correct numbers until it acclimates properly to the actual map and the zone. So in this instance, when we look at this map here specifically, first, my map is rotated 90 degrees. So we'll take it and we go image rotation 90 degrees clockwise, right? That's the first thing that's different between his map and my map. The second thing that's happened is my map starts at a random location, not random, at a location that is there, give or take. You can't even see these blue lines. There they are. So it starts somewhere out here like that. And the reason that it starts out there is because it's set based on the center of the galaxy, not based on the center of Earth. All of the maps for Bellatrix are centered by galaxy position. So looking at the master galactic map, hoping we don't crash my computer doing all this, this is where everything is centered. So Earth sits right here on the galactic map, right? So when we talk about how Bellatrix rigs into the system, this is how everything sets based on an XYZ coordinate right here in the center of the galaxy out to here in these rings. So it's going to start on ring 310 and move this way across the rings into that position. And it's I band, the letter I band at 310. I have all of these maps set up for this. We just need to come up to the conclusion as to where everything is relative to where his X, Y, and Z is versus where my X, Y, and Z is. And then we're done. We're out. We're good. Everything's fixed. We're fine. And the maps can start to be built. I'm excited about this. I mean, I know that everybody's kind of like, well, you're crazy. However, my maps will be accurate, and that's the important thing. So down here, he talks about putting Bellatrix right at the opening of the Merzem tunnel. So, cool. Cool, guys. Hey, guys, we did it. We got the math done. Math is done. That's awesome. It's good to see you, Ghost Hand. I'm glad you were here today to join with me today and everything like that. I know that we have Brent here in spirit because he's probably working right now. And so there is that. And I had someone else watching me too. And so, whoever you were, thank you for joining me today. In the meantime, I'm going to go get lunch because lunch sounds good. And you should too. And I'll see you tomorrow for Artist Check-In Friday. And I think I'm going to be excited to be able to tell everybody that I am done with the math and into the maps. So, hoping that that'll work. Anyway, now that we have verified where everything is, we can just trust that all of the other data in there is straight, and then we don't have to worry anymore, and all is good and stuff. So until next time, I will say I will see you tomorrow, and until then, keep your eyes on the stars, my friends. Bye-bye. Computer, good night.